Hi, I'm Kenton Shepard. I'm a Certified Master Inspector, that's CMI. I'm a Certified NACHI Course Instructor. I'm also an inspector. I founded the Peak to Prairie Inspection Service in 2001. I've had three building-related books published. First in '93, that's the Job Site Phrasebook series. And I want to say thanks for taking the course. The course title is Inspecting Hot Water Tanks in Residential Units. The objective of the course is to obtain an understanding of how to inspect the hot water tanks in a single residential dwelling unit, including fuel and electric hot water tanks. Completing this course should enable an inspector to identify components of gas-fired and electric hot water tanks, recognize defects and safety hazards in relation to modern standards and requirements, explain how a flammable ignition resistance system works, the importance of temperature and pressure relief valves, and checking confined spaces. This is not a code compliance course. There are many codes and they change regularly. This level of inspection is beyond what an inspector would do on a general home inspection and exceeds INTRNACHI's standards of practice. We will read text from modern building standards, we will apply these standards in a mock-up studio setting, and then we will perform inspections of hot water tanks at existing residential homes. We will watch and learn from a master plumber as he inspects 2 hot water tanks, 1 gas and 1 electric. At the end of the course, we will go over some suggested language that can be used in an inspection report. An inspection report should describe and identify in written format the inspected components of the system and should identify defects that were observed. General comments. A water heater is any appliance that heats potable water and supplies heated water to the distribution system. Some water heaters can be used for space heating. Water heaters are potential explosion hazards if not properly installed. There are instances in which hot water tanks with improperly installed safety devices have been propelled through floor and roof structures and over 100 feet into the air. So inspectors want to be really sure as they look at hot water tanks that they see a pressure relief valve. And just take a look at the fittings and pipes in general. Things can get clogged. If you look around online, you'll be seeing photographs or videos of exploding water heaters, and they look like missiles taking off. You really want to be careful. You want to protect your clients. Sacrificial rod. Water circulating through a hot water circulation system becomes chemically inert and does not corrode the piping. But water heaters have a constant supply of fresh water with lots of corrosion-causing oxygen. Because of this, water heaters are prone to corrosion. As a result, water heaters usually have an anti-corrosion rod or sacrificial rod installed. Sacrificial anodes are typically magnesium or aluminum. The rod is immersed inside the water heater tank, allowing the chemical reaction from the fresh water to attack it rather than the tank. In some cases, rods are replaced regularly. So there's a rod that goes down inside the tank, and it's made of a metal which is less noble than the metal from which the tank is made. And a noble metal is a metal which is resistant to corrosion. So the less noble metal is the metal which is less resistant to corrosion. This is it right here. The hot water pipe comes down and attaches to the sacrificial anode, which runs down inside the tank. Now the sacrificial anode is not hollow. It's not a pipe. So for hot water to be pulled from the tank, it enters through a hole near the top of the sacrificial rod, right up here. And then on out to the house. Drain valves. A water heater must have a drain valve installed for service, maintenance, sediment removal, repair, and replacement. The valve inlet is 3/4 inch nominal pipe size. The outlet is standard 3/4 inch male hose thread and a straight through waterway of at least 1/2 inch in diameter. This is the drain valve down here. This one is made of brass, which is high quality. They also are pretty common in plastic. And the problem with the plastic drain valves is that over time they become brittle, or they break more easily. They don't close all the way very well, so they tend to leak sometimes. You'll also notice that the drain valve is threaded, and the threads are to accept a hose so that it can be drained. Bradford White suggests draining the tank once a month, draining a gallon a month out of it, just to get sediment out, but they should be drained at least once a year. It's more important to drain them in areas of the country where there's a lot of hard water. Sediment will build up more quickly. That's also true for homes which have a well which have water which is not well filtered. You want to drain them to drain enemy sediment out of the bottom of the tank. Sediment can sometimes corrode the tank depending on the sediment composition. It can wind up plugging apertures and clogging pipes over time. So it's just a good maintenance practice to drain your water heater at least once a year, so you can recommend that to your clients. Water heater access. Water heaters should be accessible for routine inspections, maintenance, adjustment, repairs, and replacements. Manufacturers usually make access recommendations. Access means to reach the hot water heater by possibly first removing a panel, door, or similar obstruction. Access does not include the removal or destruction of finished materials such as drywall, paneling, or built-in cabinets. A walkway, workspace, or platform may be necessary to provide a safe path to travel to and work on a water heater. So you need to be able to get at the water heater. A service person needs to be able to get at it to make adjustments, to examine the burn chamber, or to replace it if necessary. Inspectors need to be able to get at it to assess the general condition and to get a look at the label. And sometimes the way it's installed, the label is back against a wall, or it's turned so that it's really hard to get at and see. Sometimes, especially if your camera has a macro feature on it, you can stick your camera back in there where you can't actually see it yourself. You can get a photograph of it. So at least you can provide your client with the information, including the capacity and the year and the model and serial number and that sort of thing, the information that's on the label. Potable hot water expansion tanks. A pressurized expansion tank is a sealed cylinder divided by a flexible diaphragm. An expansion tank provides space for the water to expand as it's heated and keeps the water pressure in the normal pressure range while the water heater is operating. The expansion tank is designed and intended for water storage at a maximum pressure of 150 pounds per square inch and a maximum temperature of 200 degrees Fahrenheit. This tank should be pre-charged at 40 pounds per square inch. The tank should not exceed 80 pounds per square inch charge. The tank can accept 1 to 3 gallons of water depending on the tank size. So the maximum design pressure is 150 pounds per square inch and the maximum design temperature is 200 degrees Fahrenheit. But the maximum practicable pressure should be no more than 80 pounds per square inch. And you often won't see a gauge on an expansion tank, but you may see one on a boiler, so you'll know what the pressure system is in some situations, not always. And the seals on most plumbing fixtures are only designed to handle about 80 pounds per square inch, so that's another consideration. Now there are different configurations in which you might find an expansion tank. The best choice, the best of three, is the one in which you see it here, in which the expansion tank is hanging downward. The second best choice would be if the tank were upside down. So if you were to flip this 180 degrees, that's the second best choice. The third best choice would be if this tank were turned 90 degrees so that it were horizontal. But because of the weight of the tank, which can be anywhere from 15 to 35 pounds depending on the size of the tank, an inspector needs to make sure that the tank is strapped to something up above, usually the floor joists, to help support its weight, take the pressure off the pipes and fittings. Tankless coils from boilers. Tankless coils are an indirect method of heating potable water with a boiler. A cold water supply pipe extends into the hottest part of the boiler water. The water in the copper tube is kept hot by the boiler water. When there's a demand for hot water, water flows through the tube, through the hot water boiler, and water is delivered to the fixture. So there's no tank, and as cold water supply goes into the boiler, it enters a copper tubing coil, and that extends the length of the time that water spends inside the boiler so that it can be heated. And once it's heated by the boiler, then it passes to different plumbing fixtures in the home, enters the distribution system. In addition to hot water, gas-fueled water heaters, and electric water heaters, there's a third type of water heater called an indirect water heater. It's called indirect because it doesn't actually heat the water through its own combustion chamber or through electric elements. Instead, water in the tank is heated using a heat exchanger. A hot fluid, usually a glycol solution, is circulated through that heat exchanger, through the copper coil inside the tank, and that fluid is preheated by a boiler. So cold fluid enters into the boiler, is heated, and then goes through a pipe into the bottom of the indirect water heater, and then is circulated through a coil inside the tank, and transfers the heat from the fluid to the water in the tank. And then the fluid leaves the top of the tank and goes around and re-enters the boiler to be reheated. And hot water from the tank is then enters the distribution system for the house. Water tank locations. Installation of water heater tanks which use solid, which is oil, liquid, or gas fuel should not be permitted in a room containing air handling machinery when such room is used as a plenum. If there's a malfunction of the water heater or its venting system, there is a potential for toxic combustion byproducts, such as carbon monoxide, to spread throughout the dwelling. The air handling system can also produce negative and positive air pressures and affect the drafting or venting of the water heater. The negative pressure produced by a plenum could overcome the natural draft of the water heater's venting system and pull flue gases into the room. So you don't want this water heater to be installed in a room with a return air or return air register or a fan or some other component which could pull air away from the water heater and draw the products of combustion out of the exhaust fluid into the living space. Doesn't matter whether it's induced draft or natural draft. You just want to make sure that there's plenty of combustion air provided for the water heater for proper combustion. There are other limitations on where water heaters can be installed. They cannot be installed in storage closets, bedrooms, or bathrooms. Fuel-fired water heaters should not be installed in a room used as a storage closet. Fuel-fired water heaters should not obtain combustion air from sleeping rooms, bathrooms, or toilet rooms. This does not include electric water heaters because they don't pull oxygen from the room and they don't give off combustion products. So we're talking about storage closets, bedrooms, and bathrooms, and I've found water heaters in all three, combustion waters in all three, and you will too. People will install them wherever it's easiest and least expensive. So you need to be sure and call any water heaters you find in an area in which combustion could be a health problem. Water heaters in garages. A hot water tank with an open source of ignition should be elevated not less than 18 inches above the floor of a garage. There is an exception for appliances which are listed as flammable vapor ignition resistant, FVIR, which is basically a sealed combustion chamber. This will vary with the area in which an inspector is inspecting. It really is determined by the local authority having jurisdiction, AHJ. So inspectors should take the time to find out what the requirements are in the areas in which they inspect. It's meant to prevent explosions. A lot of people keep gasoline tanks in their garages, and tanks can leak, gasoline can pool on the floor, and fumes will stay close to the floor. So the idea is to get the combustion chamber up above those fumes. So 18 inches is the typical dimension. You want to find out whether Bradford White recommends that if they have a sealed combustion chamber, a flammable vapor ignition resistant, that's resistant chamber, that it can sit on the floor. But various jurisdictions may require it to be elevated anyway, and they have the final say. This is not a code compliance course, and we're not out to do code inspections. We do home inspections. But it's important for inspectors to be able to explain to their clients what sealed combustion chambers are in water heaters, what flammable vapor ignition resistant FVIR chambers are, and what their limitations are and why they're necessary for safety. Water in a fuel-fired water heater is not just heated by a burner heating water in the tank in the burn chamber. It's also heated by the flue. This is the flue right here. And the flue also acts as a heat exchanger. If exhaust gases from the burner were to shoot right up and out of the flue, you'd lose the benefit of the heat from those flue gases. So we have a device designed to slow those flue gases down, to lower the velocity, so that they can transfer more of their heat to the water as they pass through the tank. We're able to take a look at that. This is called the helix. It's important for inspectors to know that this is there because over time, the helix can corrode and deteriorate, and because it's right above the burner, one of the defects you can find is that a chunk will break loose and fall down onto the burner. So if you look into the burn chamber and you see a chunk of steel laying on, corroded steel laying on top of the burner, there's a good chance that it's part of the helix. Confined space and combustion air. Confined space. If the volume of space in which the appliance is located is less than 50 cubic feet of space per 1,000 BTU per hour of aggregate input of the appliance, then it's a confined space. "50 cubic feet equals an area 2.5 feet by 2.5 feet by 8 feet high." So if you want to calculate a confined space, let's use this water heater as an example. We use the input here, which is 40,000. So it's we look here and it says per 1,000 BTUs per hour. So 1,000 would go into 40,000 40 times. So we take 40 and it's multiplied by 50 cubic feet. 40 times 50 would be 2,000. So to have a, if the room in which the water heater is located is less than 2,000 cubic feet, then the water heater is located in a confined space and needs to have outside combustion air supplied. Or it needs to have another method of supplying combustion air. Sometimes louvered doors or some other method, but if it's just an enclosed room with 40,000 input BTU, a confined space would be defined as 2,000 cubic feet or less. Cubic feet would be calculated by the square footage, the length times the width times the height of the room times the height of the ceiling. Unconfined spaces. In unconfined spaces in buildings, air infiltration through the building envelope may be adequate to provide air for combustion, ventilation, and dilution of flue gases. However, in buildings of tight construction, for example, buildings which are weather stripped, heavily insulated, caulked, which have vapor barriers, additional air may need to be provided. So it used to be when homes were built, they designed combustion appliances to pull air for combustion, at least some of it, through the building envelope. It's around windows and doors, even through walls and floors. But with modern energy codes, houses are often built so tightly that they don't have the same air infiltration through those areas. So you wind up with poor indoor air quality, and you can wind up with combustion appliances which don't operate very well. So if a home is really tightly built, inspectors need to be looking around to see whether there's been additional ventilation provided. Like a heat recovery ventilator is one method they use fairly commonly. It's called an HRV. There's a home here in Boulder which was built to take advantage of solar heating, and it's so efficient that it wasn't required by the local authority having jurisdiction to have an alternative heating system. It's heated completely by solar energy. One of the ways they made it really energy efficient was to build it super tightly, and they used 2 layers of drywall on all the interior walls. They had to provide extra ventilation, and they discovered that they needed to provide extra ventilation by firing up the combustion appliances and discovering that it sucked all the water out of the plumbing traps. So they made allowances for that by adding a heat recovery ventilator, an HRV. Solution. This is the solution to the confined space problem. 2 permanent openings to adjacent spaces should be provided so that the combined volume of all spaces meets the requirements. If the building is sealed so tightly that infiltration air is not adequate for combustion, combustion air should then be obtained from outdoors. So if the confined space doesn't provide enough combustion air, then you can connect it to the adjacent rooms through an opening of some sort. If the sum of the cubic footage of the combined space plus the adjacent spaces is inadequate to provide enough combustion air, then you have to provide combustion air from the outside. All air from inside the dwelling. If all combustion air is taken from inside the dwelling, then 2 permanent openings should be installed. One opening should be within 12 inches of the top and one within 12 inches of the bottom of the space. Each opening shall have a free area equal to a minimum of 1 square inch per 1,000 BTU per hour input rating of all appliances installed within the space, but not less than 100 square inches. All air from outdoors. If all combustion air is taken from outdoor air, then one opening should be within 12 inches of the top and one within 12 inches of the bottom of the space. The openings are permitted to connect to spaces directly communicating with the outdoor air, such as ventilated crawl space or ventilated attic space. Each opening should have a free area of at least 1 square inch per 4,000 BTUs per hour of total input rating of all appliances in the space when using vertical ducts. And it's 2,000 BTUs per hour if using horizontal ducts. So horizontal ducts require larger opening. Seismic supports for tanks. In those areas determined to have a high earthquake risk, it's important that a water heater be fastened in place with 2 straps to avoid damage. Strapping should be at a point within the upper 1/3 and lower 1/3 of the tank's vertical dimension. So the upper strap has to be in the upper third, the lower strap has to be in the lower third, but you have to maintain 4 inches clearance above the controls. Dip tube holes inside tanks. A typical design of a water heater tank includes a cold water dip tube. The tube directs cold water to the bottom of the tank. At the top of the tank, a hole is installed in the dip tube to prevent water from being siphoned from the tank through the tube. A hole is required to be located within 6 inches of the top of the tank. So let's take a look at the dip tube on this tank. We'll just pull this expansion tank off, set it down right over here. The dip tube slides down into a hole in the top of the water heater and screws into place. So we'll just unscrew this one, and you can see there's the anti-siphon hole right there, and it's within 6 inches of the top of the water heater. So cold water goes into the water heater through the dip tube and is deposited, and it comes out the lower end of the dip tube at the bottom of the tank. That's because the combustion chamber and burner are at the bottom, and we want water to be heated down here where it'll rise to the surface, so hot water is at the top of the tank, and then will be pulled off and pulled off to the distribution system. You'll notice at the bottom of the distribution tube there are slots in the tube. On the bottom of the dip tube there are slots in the dip tube. Those are designed to create turbulence. As water flows down the tube and hits those slots, it moves out into the lower area of the tank and creates turbulence, which helps prevent sediment from floating down and resting in the bottom of the tank. Sediment will shorten the life of the tank itself. TPR valves. Combination temperature and pressure relief valves do two things. They open water and release water out of the tank if the temperature exceeds 210 degrees Fahrenheit, which is just below the boiling point. And two, they will open if the pressure in the tank exceeds 150 pounds per square inch, the maximum normal operating pressure for a water heater. So this is the TPR right here. We can unscrew it, take a look at it. There's a plate, a data plate on the front, which provides various information about the maximums. The information on here will be the same no matter what the manufacturer is, but just as a reminder, it gives the maximum pressure, which is 150 pounds per square inch, and the maximum temperature, which is 210 degrees Fahrenheit. Inspectors don't test these. If you test it, you never know what might happen. It might not close again, and then all of a sudden you'd have water everywhere and no way to, and you have to shut it off up here, but then you'd be responsible. So they're actually pretty hard to operate. I'll put it back on in just a second, but first I'll explain what this is. This extends 3 inches into the top of the tank where the water is the hottest. This is filled with wax, so this is connected with the temperature release. As the temperature increases, the wax inside this tube expands and pushes on a spring. And once it reaches the preset limit, it will open this valve and allow water to come out. The pressure part of the TPR works the same way in that it pushes on a spring, but the water pushes directly on the spring and operates the valve if the pressure exceeds the preset limit, 150 psi. We'll put this back on. One thing that you might want to watch out for, especially in confined spaces, as you're moving around the water heater, looking at the label, trying to see behind it if you need to, it's kind of easy to catch a sleeve on that. But and inspectors are always worried about tripping the valve and operating it when they don't want to. But this is actually pretty hard to operate, and most likely you'll tear a sleeve before you'll operate the valve. We should mention the Watts valve when we're talking about TPR valves. Some gas water heaters use a temperature cutout, which is the Watts 210 valve. This is a valve installed in the gas supply line to the water heater. So the Watts 210 valve is not a TPR. Its limits are tied only to temperature, and if the temperature limits are exceeded, it will cut off fuel supply, the gas supply. Location of the TPR valve on the water tank. In order to properly sense the tank's water temperature, the TPR valve should be located in the tank in the upper 6 inches of the hot water tank, where all the hottest water is located. The location is more important for temperature than pressure, since the pressure is uniform throughout the tank. To prevent heating the water above 210 degrees Fahrenheit, the TPR must be installed in the hot water in the top 6 inches of the tank. Relief valve importance. Water is essentially an incompressible solid. That means when you apply pressure to it, it won't compress. It will retain the same volume. It has no latent heat energy within itself to expand when released unless the water is superheated. Water above 212 degrees Fahrenheit is superheated water, and superheated water would really like to turn into steam at atmospheric pressure. Let's say we have a couple of failures on this tank. Let's say the TPR fails and it's corroded for whatever reason. Once the pressure or temperature inside the tank exceeds the limit, it's not going to come out through the TPR valve. Let's say also that the limit switch fails and the burner does not shut off when it's supposed to and keeps on heating water in the tank. The temperature at which water boils varies according to the pressure in the tank. The higher the water pressure in the tank, the higher the boiling point. Once the temperature of water inside the tank approaches that boiling point, it wants to turn to steam. Once it exceeds the boiling point, it becomes superheated water. Superheated water really wants to turn into steam, but it can't because it's not exposed to the atmosphere. So, and since water is not compressible, it begins to push on the outside, push on the tank. It wants to spread. It wants to expand. At some point, that outward pressure becomes so great that the tank will rupture, and when it does, it'll rupture explosively. It will rupture at the point at which the tank is the weakest. A lot of times that's at the base of the tank because that's where the majority of the corrosion takes place. So if, because of the failures of the TPR valve and the limit switch, pressures exceed the limitations of the tank, the design limitations, and it explodes through the bottom of the tank will take off like a missile. It may rupture somewhere else also, depending on the design. It'll find the weakest spot. It might be on the side. In that case, the tank will explode to the side. At any rate, it can be a huge explosion and with a lot of risk to life and limb. Let's assume that a water heater tank has 30 gallons of superheated water inside it. Assume 50 pounds per square inch, and the water temperature is superheated to 300 degrees Fahrenheit. Remember that superheated water really wants to turn into steam. If the tank ruptures, then 30 gallons of superheated water will instantaneously turn into steam in an outward direction through the rupture. 1 cubic inch of water turns into 1 cubic foot of steam. That's how great the expansion is. So they create huge explosions. Discharge pipe on the TPR valve. The following are 13 requirements for a discharge pipe serving a TPR valve. Number 1, the pipe should not be directly connected to the drainage system. The pipe should discharge through an air gap located in the same room as the water heater. In other words, the pipe shouldn't go down through a hole drilled in the concrete floor. There should be an air gap, so the discharge should leave the discharge pipe and then enter something else. Number 3, the pipe should be constructed of materials tested, rated, and approved for such use. So you don't want people using anything laying around. Something might prevent proper discharge. Number 4, the pipe should not be smaller than the diameter of the outlet of the valve served and should discharge full size to the air gap. Otherwise, the smaller diameter pipe will create restrictions and you might still have an explosion. Number 5, the pipe should not have valves or T-fittings installed. For the same reason, it can limit discharge. Number 6, the pipe should not have a threaded end, because if it does, it wouldn't be at all unusual for a homeowner to come along and cap it off because it was leaking a little bit. And they do leak from time to time. They do need to be replaced from time to time. Home inspectors sometimes will see either some leakage in a TPR valve around the valve itself on the jacket of the tank, or sometimes you'll see on the floor, you'll see a little pool of discharge. I've seen a little cup that was half full. Number 7, the pipe should serve a single relief device and should not connect to piping serving any other relief device or equipment. In other words, if you have a home with 2 water heaters and one is directly above the other, they should each have individual discharge pipes. They shouldn't be connected to one discharge pipe, one big long one. Number 8, the pipe should discharge to the floor, to an indirect waste receptor, or to the outdoors. You just want to make sure that it has a safe area to discharge to where the damage will be zero, preferably, or at least minimized. Number 9, the pipe should not terminate more than 6 inches above the floor or waste receptor. Otherwise, upon discharge, you're liable to have water everywhere and water damage. Number 10, the pipe should discharge in a manner that does not cause personal injury or structural damage. So you don't want it aimed at head height. Number 11, the pipe should be installed so as to flow by gravity. So you don't want it forced to flow uphill. You don't want the discharge to have to fight gravity. Number 12, the pipe should discharge to a termination point that is readily observable by the building occupants. In other words, again, you don't want it terminating in a hole drilled in a concrete floor. And it's pretty common in homes with crawl spaces to see a hole drilled in the floor beneath the water heater and the discharge pipe disappears beneath the floor. Someone could come along and cap it, and you would never know until it was too late. So you want to be able to see the termination of the discharge pipe. And 13, the pipe should not be trapped. A trap would be a restriction. The termination of a relief valve discharge pipe should always be visible and conspicuous. An air gap is necessary to prevent backflow and contamination of the potable water system. The discharge pipe must not be reduced in size and must not be less than the size of the relief valve outlet. A reduction in size will act as a restriction and would impede the flow rate of the discharge. Relief valves must not be exposed to freezing temperatures because ice will result in blockage of the discharge. The discharge pipe should have a minimum pressure rating of 100 pounds per square inch at 180 degrees Fahrenheit. Water heater temperature relief valves are usually set to open and discharge at 210 degrees Fahrenheit. Flammable vapor ignition resistant system. That's FVIR water heater. In 2003, a new standard for water heaters was developed and phased in. It says the water heater should not ignite flammable vapors outside the water heater created by the spilling of gasoline onto the floor. The Consumer Products and Safety Commission found thousands of fires, injuries, and deaths were related to water heaters. Most of these cases were because of improper storage or handling or spillage of gasoline. If the tank is in compliance with the FVIR standards, it does not have to be raised 18 inches in garages or similar locations unless it's required by the manufacturer or local code authorities, the authority having jurisdiction. This tank is FVIR compliant, and we're going to take a look at the different components. All FVIR water heater tanks have things in common. Number 1 is a flame arrestor plate. Located under the burner, the metal plate is designed to allow combustion air into the combustion chamber, but keep flames from escaping downward and igniting flammable vapors below. So this is it right here. The flame arrestor plate is along the bottom of the water heater. Number 2 is the thermal cutoff switch. It's designed to shut down the heater if it senses excessive temperatures caused by inadequate combustion air inside the chamber. So this is the thermal limit switch right here. These two red wires are connected to it. A lint, dust, and oil screen. This screen is designed to protect the combustion process from lint, dust, and oil. The screen openings can become clogged, especially when the tank is located in a basement or utility room. You can just see it down there in the bottom of the of the burner chamber. So this is how the Bradford-White FVIR system works. Combustion air is pulled from the room. Let's just say this is in a garage, so there may be ignitable fumes down near the floor. The combustion air containing fumes is pulled through these slots in the water heater jacket and down through to the underside of the combustion chamber. From there, it enters up through holes in the bottom of the combustion chamber and passes through a screen which increases its velocity and changes its direction. If the combustion air in the chamber has excessive concentrations of flammable gas that ignite the pilot and burner, there will be a limited explosion, and the thermal sensor, will sense that and shut off flow of gas to the burner and pilot. When that explosion takes place, there will be flames, and they'll be directed downward, but the flame arrestor plate will prevent those flames from coming out into the room and igniting gases in the air near the floor, which prevents the garage from exploding. So that's how the Bradford-White VFIR works.
Hi, I'm Paige Peters with Natchez TV, and today I'm joined with Jerry Morawski of Bernie's Plumbing and Heating in Boulder, Colorado. He's going to show us how to inspect a water tank. Hi, Jerry.
Hi, Paige.
Let's start with this one since it's right here. What kind of material is this inside?
This is glass lined. They spray like a porcelain on the inside of here. That way, if it was just plain steel, it would rust out really quick.
And what's this tube right here?
That's a good question, Paige. That's what they call a dip tube. What it does is cold water comes in your cold side over here, and it brings the cold water down to the very bottom of the tank. So that way, the burners on the bottom can heat the cold water. As the cold water heats, it rises. The other side doesn't have a dip tube. Hot water just goes right out the top of the water heater. This is a 40-gallon water heater, so you pretty much have about 40 gallons of hot water before you run out.
And what's that metal rod back there?
They call that an anode rod, also known as a sacrificial rod. What it does is when the minerals come in with the cold water, it'll attack that rod. It's a magnesium rod instead of attacking the side of the tank.
And how about the baffles inside the tank?
These baffles are here. They're designed for creating the heat to go along the side of this, so it will heat the water quicker. Also, it slows down the heat in the bottom of the burner compartment. Sometimes if it doesn't have this, it'll blow the burner right out because the air is just flowing too quickly.
And is this tank insulated?
Yes, it is. It has a foam insulation between the tank and the outer jacket.
Do you recommend that people buy extra insulation for their water tanks?
That's a good question. A lot of people like to buy those water heater insulation covers that they wrap the whole water heater with. One thing you should know about that is it does void a warranty. Usually a water tank is 6-year warranty or 10-year warranty. After that, go crazy.
So now on the outer side of the tank, what's all this right here?
This would be your gas valve and temperature control. It has a button here for lighting the pilot, turning it on. The new water heaters, they now have a electric ignition, similar to your gas grill. Here's your temperature control. Usually you set that to when you first start it up, right where that square is, and then check your water temperature and see if you want it higher or lower. If there's small kids in the house, you usually want it to be set around 120 degrees.
And what should an inspector be looking for in the chamber? Can you explain the flames in the chamber?
Yeah, the chamber's right down in here. And they have a lot of safety stuff on these now. They're required by code. This is a high temperature switch. It'll shut the gas valve off if the temperature gets too hot in the combustion chamber. Sometimes they get too hot because the screens here are just full of dust, dog hair, whatever, and then you're paying a plumber to come out to service that. And they have fire arresters in them. Basically what that means is it's not going to allow any flame or anything to come out of the water heater. Like say you have a gas can nearby, which you should never do, or paint. It's not going to ignite them fumes. There's only one way that the flame can go. This is just a drain valve. Some people say you should drain these every year. You can if you want. Some water heaters have a plastic valve. Sometimes you can never get them shut off. They fail.
Is there a screen or anything that a homeowner could clean to keep regular maintenance?
Well, on this one, it's kind of hard. You don't really have a removable screen that you can clean off or vacuum off. On other water heaters, there's a screen that goes right under here. It's a little black screen. You can remove it, clean it off, and you can just put it right back on. And then that will prevent the burner chamber from overheating.
So what if a home inspector sees scorching outside the burning chamber or damaged wires?
Well, usually on this type of water heater, you don't really see the scorching, but on the older type, you would see sometimes some dark discoloration on the tank. Usually what that means is either the baffle is clogged or the flue is clogged, and that definitely needs to be addressed. It's creating carbon monoxide to come into the building.
And over here, what's this, all of this here?
This is all your gas line. Gas would come in down through here. This is a drip leg. Mm-hmm. This is a gas cock. It's kind of on this installed in the wrong area. It should be installed before the drip leg. That way if you ever need to clear out the drip leg, you can do it just by shutting the valve off. This is a union. Basically, this comes apart so you can remove the water heater and put a new one in.
So what's the most important thing about the label that a home inspector should look for?
Well, this is your rating label here. They call it a rating plate. It'll have your model number. It'll have your serial number, the capacity in gallons, input BTUs an hour. This is a big one here, natural gas or LP gas, liquid petroleum, or propane. That's pretty much it. You could usually find out how old a water heater is within the serial number. All different makes of water heaters have their own way of putting that in their serial number. With knowing how old a water heater is, that'll tell you if it's getting close to time to change the water heater out. Usually a water heater lasts about 10 to 14 years.
And if a tank has a puddle around it, does that mean that you should replace it?
Usually it does, but you're going to want to check out other things, such as you have a temperature and pressure relief valve up here. Sometimes what happens is the pressure can be too high. It's usually the pressure is too high. Sometimes if the temperature gets too high, it'll cause the pressure to blow off because of expansion. That's one thing. Another thing is if the tank is bad, you're going to find a lot of water down in the burner chamber. Also, these tend to leak up here as well sometimes. Sometimes you'll see water coming out of there or out of here. That usually means that the tank is bad. It needs to be replaced.
So what is this right here, and what does it do?
This is a temperature and pressure relief valve. What it does is if the pressure gets too high from thermal expansion, there's a spring in here that'll release and it'll blow the water down onto the floor. This usually, for code, you need a tube that goes down to the floor That way, in case ever it is blowing off and you need to get over to the water heater, you're not going to scorch yourself with steam.
Should a home inspector ever manually test this valve?
No, they shouldn't. There's a rubber washer inside there, and sometimes when you crack it open, it won't seat right. There's going to be rust in there and everything, and then it'll just continue to drip.
And what if this is dripping?
You need to check the water pressure, usually down here at the boiler drain down there. You can check the pressure. This is rated at 150 psi. If it exceeds that, it's definitely going to start dripping. 2 cases of high pressure, cause of high pressure would be thermal expansion, or your pressure reducing valve coming into the house has failed, and it could just make it start dripping.
And how would you know if it's pressure coming into the house or thermal expansion?
Well, like I said, you could put a pressure gauge on your boiler drain down here, and then you can, with the burners off, you can run some water, and if you see it, the pressure climb, usually that means that the pressure reducing valve coming into the house is bad. Now if it doesn't climb and you turn the burner up with nobody running water within the house and you see it slowly rising, that's thermal expansion.
And what's this tank right here?
This is a thermal expansion tank. When your water heats up, it expands and it has nowhere to go because it cannot go back to the street because of the backflow preventer that is coming into the house. So it goes in here. There's really no way an inspector can test this other than putting a gauge on the boiler drain at the bottom of the heater and turning the burner up. And then if you see that gauge going up, usually the case is that this went bad. The bladder is shot, and another thing with these is they need to be installed on the cold side of the water heater. Right here you can see on the top of this tank it would have water in it. Well, there's a bladder in here with an air cushion. As the thermal expansion increases, this absorbs the expansion, whereas you don't have any other TMPs blowing off, or sometimes faucets like to drip when the pressure is too high.
So do all the valves need to be ball valves?
Not necessarily. Today they're putting all ball valves on. They are really good valves. They will shut the water off all the time. I have 2 more valves here. This is a globe valve. You don't see much of these anymore. They have rubber inside of them, which the rubber will wear out. This is a gate valve where, if you can see that, it's got a little gate in there. Sometimes these do fail. All these valves are full open valves. Now if you use this for a regulator valve, it's going to wear that gate out and then it'll never close again. So then you're paying your plumber to replace the valve. Some of these valves, they have direction of flow, like this one right here does. It's got a little arrow on there. Ball valves, I usually don't see too many arrows on those because they can be turned any which way you want. But you want to be sure you know that some of these valves have arrows on them.
And what's this right here, and what kind of tube goes on that?
That's your diffuser for your flue. The burners burn the fuel. It comes up through the water heater and goes out. Now this will take 3-inch and 4-inch flue. One thing you got to look out for is when you have single wall flue, it can be no less than 6 inches from any combustible materials, meaning like wood, insulation, drywall. It can go right next to a gas pipe because it's not combustible, it's a metal pipe. Once you go to double wall flue, you can be within 1 inch of combustible materials.
And how does the flue connect to the diffuser?
Well, it just slips over here, and then usually you put 3 sheet metal screws all around here. You need 3 sheet metal screws at each joint as you go up. One thing you should know is when you need to go horizontal with the flue, it needs to be 1/4 inch per foot. You can't have any sags in it or anything because you'll get carbon monoxide poisoning within the house. This diffuser here is designed so if you get wind coming down the flue, it's going to bring the wind out instead of going down and blowing out your pilot light.
And what if an inspector were to find aluminum tape or duct tape connecting the flue to the diffuser?
Well, aluminum tape isn't good for a heat pipe, and duct tape obviously is a combustible material. So you don't want to have that on there, you just want to use the screws.
And what's this piping here? These two look pretty drastically different.
This is a flex line. You can flex it in any direction to hook up to the rest of your plumbing. And this is hard piped. This is what I like to do. These restrict the flow.
And are there different types of copper piping?
Yeah, there is. This is type M. It's a thinner wall. Type L is a thicker wall. Type L is obviously going to be a lot more expensive nowadays, but type M works just as well.
And what's this big pan for?
That's a good question, Paige. This is a pan to hold the water heater if it's located on an upper floor other than the basement. Usually a basement has a floor drain nearby, so if there ever was a leak with the water heater, that water would go right down the floor drain. But if you're on a first floor or second floor, that leak is going to go into this pan, and then the plumber would plumb this to a floor drain within the house. That way, if the water heater ever does go, you're not going to be flooding the whole building.
So what are these used for, and should an inspector be looking for them?
Yeah, this is Teflon tape. It's a white tape. You can put it around your pipe threads. Like on your gas line here, you're going to want to put that on every joint. Some guys like to use this and only this. Some guys like to use this and only this. Some guys like to use both. They put this on and then that on. As you can see, this one doesn't have a sign of any tape or plumbing pipe dope on here. So in that case, that would be something an inspector would call out on.
And what's this right here?
That would be a flexible gas connector. Sometimes when you change a water heater out, this line here won't line up with the gas valve here, so they'll use a flexible gas connector between this T and this gas valve. This has a union on it, just like this one. This comes off. You can screw this into your gas valve, then put this back on, and then the other side will have the same thing. Goes into the T.
So you changed this around. What was wrong with it before?
Before, the gas valve was over here before the drip leg. You want to have the gas valve before the drip leg, so if you ever have to get debris out of this drip leg, you can just shut the valve off, pull this out, dump it out, put it back on, turn this on, relight your water heater, and you should be all set.
So we're at an electric water heater now. Is the inside of this the same as the gas water heater?
It is in a way. It's coated with the same material. It doesn't have a burner chamber on the very bottom and a flue coming up through the middle. It has 2 elements, one high, one low. It has a dip tube, an anode rod, or they call it sacrificial rod. Insulation's a little bit thicker on this one. You got a T&P. This one's located on the top. Doesn't really matter, but that's located there. This is where your power comes in. Electric water heaters are 220. Obviously, this isn't the right wire or breaker or anything. Whoever plumbed this, they plumbed it 1/2 inch in, 3/4 out. Usually when it's done that way, it depends on the house plumbing. These are where your elements are inside here. You have a drain valve. You can put a hose on there and run it outside or into a floor drain. Basically, with these water heaters, one thing to know is it heats the upper element first. When this thermostat in here is satisfied, then it'll switch it to the bottom element, and then it'll heat the rest of the water.
So what is this?
That's basically the connection where your wires hook up to. It's also the thermostat. Here is a setting down here. Right now it's a little bit below 125, probably right around 120. And this is located right up here under this plastic panel. This plastic panel is for your safety so you don't get shocked. The wires come from here and they go down to the element. The element heats the water. Once this thermostat is satisfied, then it'll bring power down to the lower element and start heating that water. Usually a thermostat is set to around 125, 130. What if you have small children? Once again, 120 is good so they don't get scalded. They have more sensitive skin than us adults.
Sometimes home inspectors find water streaks in this area. If they found that, what should they report?
Usually the water tank has a leak. It may be coming from where the element comes into the water tank. Or it could be a leak up in here and it's just flowing through the insulation and coming out that area. It can also come out this area too and out the bottom. Usually that means you need a new water tank.
And I noticed that this water heater has the same valve as well.
Yeah, this is the temperature and pressure relief valve. It's located on the top. One thing about this one, it should have piping that goes down to the floor. That way you won't get scalded if it ever blows off.
Is there something an inspector can do to check the temperature of the water?
Yeah, he can run a faucet on hot only and run a thermometer through the water. If that water changes colder drastically, usually that means that the dip tube had either fallen in or it had disintegrated. These are only made of plastic and they don't last forever. The gas water heater, same thing. They deteriorate or fall in. They're only connected by the top here by very little plastic. Some of these water heaters, they have these little slots in here. Supposedly they're self-cleaning. They clean the bottom, keep the water stirred up so anything that collects in there is going to go out, and just keep the water heater clean. Sometimes when you have a sediment on the bottom, like mineral sediment on the bottom of a gas water heater, is what happens is when that water heater starts heating, you can hear it popping. That popping noise is just the settled minerals just expanding in the bottom of the chamber. But that usually doesn't happen in an electric water heater.
Is there anywhere in a house that a water tank should not be located?
Usually in a bedroom. You can't have them in a bedroom or a bedroom closet just because it's a gas burning. In a garage, it needs to be 18 inches off the floor, just because in a garage is usually where you store gas and your car is in there. Closets, like in a hall closet, it can be installed in there. It just needs to have combustion air coming into that room, and the flue needs to be vented out properly.
Does it matter how close it is to a wall or other things in the house?
Usually around the back is fine. It can be probably 1 inch away from the wall, but in the front you need 2 feet, at least 2 feet. It needs to be accessible, just because if you need to work on it, you'll have room to work on it.
So what are the requirements for combustion air?
Nowadays the code says you need to have 1 high and 1 low adequate combustion air. What they mean is you have air coming in from the outside into the water heater closet or utility room. They don't want you to be taking air from inside the building to burn the gases.
So what if a home inspector finds a utility room that's not up to code? Should he raise a red flag right there?
Not necessarily. If you had to change everything or update the house to code, you'd be changing everything in that house. It's basically grandfathered in. You can change a water heater without changing the combustion air coming into the utility room.
Thanks, Jerry, for coming out here and helping us inspect these water heaters.
It was my pleasure.
And thanks, Bernie's Plumbing and Heating in Boulder, Colorado. We'll see you next time.
Hello, my name is Benjamin Gromicko. I'm the editor of this tanks course, and I'd like to go over some of the components of the hot water tanks that we inspected with the master plumber. This is the TPR valve on top of the hot water tank. This one's on top of the hot water tank. You can have it on the side as long as the TPR valve sensor is in the top 6 inches of the tank where all the hot water is. Ball valves. The electrical connections, when I was an inspector, I always, well, that's the wrong size. That's a 12 gauge. It should be 10. And I always took off the top plate to look at the connections inside. And there's a grounding connection. Incorrect size. It's a 40 amp breaker there. Should be 30. Electric disconnects are required. I always used my digital camera to take pictures of the label. Showed everything. I didn't have to memorize everything. And there's the high quality brass drain valve with the hose thread on it. This is the inside of the electric hot water tanks. 2 heating elements, one on top, one below. This is the one on the top. Has problems usually on old tanks around here where it leaks. These can be replaced as a maintenance. Going down the dip tube to the bottom heating element there. It's a great shot. You can see the bottom of the dip tube and the anode rod. This is the thermostat, electric thermostat, and the expansion tank. We went over the expansion tank. There's a little diagram of the diaphragm and the water. Different thicknesses of the copper pipes. That's the thin pipe there. Always look at the connections at the top and look for carbon deposits dripping back from the draft inducer. You can put a 3-inch or 4-inch vent connector on top of that. There's the way you test the TPR valve on the side. This is the one on the side. It's missing a discharge pipe. This is the one on the top. They simply screw out. There's the wax, 3-inch wax stem to sense temperature, and inside there's the cap where the water can come through, and there's the springs that hold it closed. So it comes through this way and discharges out at the bottom, and all of the certification marks, the size, maximums for temperature and pressure. 3/4 inch. There's going up the dip tube. There's the anti-siphon hole, little hole at the top 6 inches of the pipe. That's up the top of the tank. There's the igniter, all the sensors going in. There's the spark igniter with a pilot flame and sensor. There's the water temperature sensor and the thermostat. Removing the cover, you can see the sealed chamber of the FVIR. Has these screws attachments, and there's a like a gasket to make it sealed. You can see some of it exposed at the edge there around the as inspectors we cannot take this off, but we can look through the wire, and there's the flame arrestor plate at the bottom of the hot water tank. and the lint and dust and oil screen. It changes the combustion air direction and its velocity, and flames can't get back out. So you can see through it. It's removable as well, and that's part of a maintenance feature. This is in the interior of the combustion chamber, and this is where the exhaust gases go up into that helix heat exchanger. There's where we can see the flames, the burner chamber, and the pilot light mechanism. To get to the dip tube, lefty-loosey, and the dip tube's on the cold, always. And you pull it right out. Plastic, polyethylene, I believe. And there are the fins or slots to make turbulence at the bottom of the tank so that the sediment doesn't stay there. And Jerry, the master plumber, said that this connection is kind of weak. It cracks off and the dip tube will fall inside the tank. And on the hot side is the anode rod, and this is where the hot water exits upwards through that connection. The anode rod isn't hollow, so there's where the hot water comes out. And if you pull the rod out all the way, we always check for leaks at the top of the tank there. It's only a pound or two. There's the interior heat exchanger and the helix part. Didn't know you could pull it out. I guess you could replace it if you needed to. If it broke apart on an old tank, sometimes that happens. We'll see chunks of it lying on the burner chamber. And there's the TPR valve on the side of the tank. TPR valve on the side of the tank, you can just screw it right out. There's the temperature probe. Sometimes that leaks right there at that area. And that's it for the photographs of all the components of a gas and electric hot water tank.
We're actually at a home and we're going to inspect this water heater. If you look down here near the combustion chamber, you can see that this has got a flammable vapor ignition resistant combustion chamber. You can tell by this plate that's permanently fixed there. You do not want to remove that plate. You can void the warranty. The plate does have a viewport, a glass viewport, so that you can examine the flame color. So the FVIR is designed to keep any flammable vapors from igniting, any vapors that might be near the floor in a garage or in a basement. If we work our way up, you can see at the gas piping here, it looks like this used to have a drip leg, which once they added the furnace, they then turned into gas supply for the gas water heater. Drip legs are designed to collect particulates and any moisture from, say, condensation, and to prevent those from getting into the gas valve and causing problems. Drip legs are required in some jurisdictions and not in others, so inspectors should take the time to find out what's required in the jurisdictions in which they're working. Even though this is not a code inspection, it's a safety feature and it's a good idea to mention that. Working our way on up, looking at the vent, the exhaust flue here, we see missing screws, and right here we see a thermally actuated vent. So inside this section right here is a damper. Actually, it's a thermally actuated damper, I should say. And it acts in a similar manner to the damper on a fireplace. There's a round piece in there that is designed to swivel 90 degrees and open to allow the products of combustion to be exhausted through the flue. When the heater is not in use and things cool down, it's designed to turn and seal off the flue so that heat isn't lost to the outside. In a few minutes, we're going to take this apart. You want to be sure that the draft diverter is securely fastened and not bent or damaged, and that there's the right size gap. That will vary by manufacturer, but if it's obviously too large or obviously damaged or obviously squashed, which you'll see from time to time, so there's hardly any space here, then you want to be sure and call that. But the draft diverter is designed to supply cool air to the exhaust flue to help keep that cool, so it's a crucial part of the system. Now we do have a proper relief valve here. There's some corrosion on it, but it doesn't look like enough to block the valve. Don't see any corrosion on near the lever here, and there's a data plate there. On that data plate is information which tells among other things, the pressure at which the valve is designed to release water, to discharge water. It also tells the temperature at which it's designed to release water. So it's 150 pounds per square inch and 210 degrees Fahrenheit. Usually those are the typical pressure and release limits. Now let's just say that on this water heater there was a lot of corrosion here and that TPR was blocked, so it couldn't discharge water. And let's say that on the thermal limit switch here that your child came along with a pair of fingernail clippers and clipped those wires, so that doesn't work either. So now we have a water heater which has no temperature or pressure relief valve, and it doesn't have sensors telling the burner when to shut off, so the burner continues to burn. Water inside gets hotter and hotter. The temperature at which water boils depends on the pressure inside the tank, and the higher the pressure, the higher the temperature at which the water in the tank will boil. So let's just say that the burner continues to burn and approaches the temperature at which water would typically boil in the tank. It will vary. We don't have to name what that temperature is right now. Water cannot actually turn to steam unless it's exposed to atmosphere. And this tank will be full of water so that no steam can be created. So at some point, let's just say there's no pressure in there and it reaches 212 degrees, which is what water usually boils at. As the burner continues to burn, it will exceed 212 degrees. And it then becomes superheated water and expands and continues to expand as long as the burner burns. As it expands, it puts more and more pressure on the water tank inside this jacket. At some point, it's going to reach a pressure at which the design limits are going to be exceeded and the tank is going to rupture. And when the tank ruptures, then the superheated water inside the tank will be exposed to the atmosphere, will turn to steam. And when water turns to steam, it expands from 1 cubic inch to 1 cubic foot. And this huge, sudden, tremendous expansion is what we call an explosion. So depending on where the tank ruptures, this tank is going to move. They often rupture near the bottom of the tank because that's where the corrosion is. And if that's what happens, then the tank becomes a missile and it goes straight up and it can go right through the floor and the roof. An exploding water tank can destroy a garage. I mean, the explosion is just huge. Let's see, I think it's a 17-inch gun on a naval frigate might have 4 million pounds of foot-pounds of pressure, and this would have about half that. So you couldn't really mount this on a frigate and have it take care of the enemy, but that's just an example of how much energy is released when one of these explodes. Now we're going to remove this thermally actuated damper and take a look inside and see if it'll actually respond quickly or if it's prone to binding from corrosion or if there are any other problems we might see. And this is far beyond what you would do in a general home inspection, but we're going to do it here for you. Somebody has left some paper near the combustion area. We don't want that. Here's the draft diverter. There we go. Oh, there we go. And you can see the damper in there, and you can see the springs designed to expand as they get hot. And it's that spring expansion that actually turns the damper. Let's see what happens. There we go. Now it's up against the stop. That's as far as it's going to go. So that took maybe a little less than a minute to actually turn that. And it's staying put pretty well just from the heat retained in the metal of the flue, the metal of the vent. And there's not really much to bind. As long as no corrosion gets between the coils of the springs, everything will stay fairly free, and that force will be pretty constant. And there's quite a bit of force there to battle just light corrosion. Now, looking at the venting of this water heater, you can see that on top of the jacket, up here, there are some granular deposits. Now, I don't know exactly what those are. And if I'm talking to a client, I'm not going to say, well, these are carbon deposits, because I don't know that they are. You really need to be honest with your client. If you don't know, tell them that. And you can offer to find out. One really good source of information is the InterNACHI message boards. So if you take a close-up picture of the carbon deposits here, and actually there are some up there higher on the exhaust flue, so there's a pretty good chance that these are connected with a combustion problem. But if you take a photograph of this problem and post it on the InterNACHI message boards, you will have inspectors from all over the country taking a look at the photographs, and there's a good chance that someone is going to know what they are, and you're able to provide your client with a little more information. But in the meantime, it's a good idea to recommend that a qualified service person take a look at this and make sure that the venting is correct, just because you don't want to have problems with carbon monoxide, or you don't want to have problems with carbon monoxide, and you don't want to have problems with corrosion from improper combustion also. We're on site in a home doing a water heater inspection, and as you can see, there's what looks like a confined space right here. We have two combustion appliances, a water heater, which is 36,000 input BTUs per hour, and a forced air furnace, which is 80,000 input BTUs per hour. when they're both in the same area, you've got to combine those two. You've got to add the values of the BTUs per hour together in calculating whether or not it's a confined space. So we've got 36,000 and 80,000. Together, that's 116,000 input BTUs per hour. Now, for each 1,000 input BTUs per hour, we need 50 cubic feet of space for proper combustion. So we've got 116,000 BTUs per hour. If we divide that by 50, we get just under a requirement of just under 6,000 cubic feet that we need to have proper combustion in here. And we don't have anything like that. Inside this room, which has a solid door, we've got about 250 cubic feet. So there are two ways we can bring in more combustion air. We can provide a way for air to come directly through the walls, either by using louvered doors or some kind of opening. If we were to replace these doors with louvered doors, the louvers would still present some kind of restriction. And calculating the restriction is way beyond what a home inspector would do on a general home inspection. The other way we can bring in combustion air is to bring it in from the outside. Typically, home inspectors would look for two 12-inch ducts, one high and one low, for bringing combustion air in from the outside. What we have here is one 4-inch duct. That 4-inch duct runs from right here about 14 feet that way. Then there's a bend and it goes up, and then there's another bend and it goes over. There's a number of bends in that pipe. It's a long way over to where that pipe goes out to the exterior. And every place there's a bend, that bend creates a restriction in airflow, which makes it more difficult for combustion air to be pulled into the mechanical room. So an inspector would definitely write this up as being a problem with combustion air and needing additional combustion air brought in somehow.
Hello, my name is Benjamin Gromicko. I'm the editor of this video course. I am a home inspector, and I have been a home inspector since 1996. And I like to go over some digital pictures that I've taken in previous home inspections that I've performed. And the first thing I start out with when inspecting hot water tanks is actually where the service line comes in at the water meter. No leaks there. Main shutoff valve. No leaks. Cross the fingers. But here's where the hot water tank inspection actually starts, at the check valve. When there is a check valve, the water system, distribution system in the house is a closed system. Expansion in the hot water tank needs to go somewhere, and it can't go back out to the street. So you go to the hot water tank source area, and there should be an expansion tank installed, a potable hot water expansion tank. This house is only a few years old, and it was passed by the local code inspector, but there's no expansion tank. And also take a bunch of digital pictures, including the label. There's a Bradford White, and has the model number, serial number. There's the year and the month hidden in the serial number. Capacity, input BTUs if you're concerned about calculating confined spaces or combustion air, and some clearances. So there's an advantage going back to this picture. There's a lot of information here that I don't have to write down. I could write down later, but I just take a digital picture of it. Drain valve, brass, good. There's the shutoff valve. According to our master plumber, it's in the wrong spot. There needs to be a drip leg, and this one doesn't actually have one. You can see this is the bend. This is the 90-degree bend. There should be a drip leg here. and the valve should be up here before the drip leg, so that if you want to clean out the drip leg, you can turn off the gas and then clean out the drip leg. And this is the union. Power inducer fan there. It's plugged in. It was functioning at the time. No leaks at the valve. Bonding, jumping the lines, connecting the lines together. Relief valve extended to the floor. These shots are great because I can, if there's ever a problem later in the life of this water heater, I can prove, I can demonstrate that it wasn't leaking at the time of the inspection, and I would actually lift this power cord off the floor. Another shot of a gas-fired hot water tank. There's the valve there, gas shutoff valve, demonstrating the heat source, thermostat, old valve. I like to see 3 screws at each connection. Extended to the floor. Again, a data plate, 1 picture. It says 1,000 words. There's the model number, capacity. There's the year. Well, that's one of the years. It was probably, here it is, B99, 1999. That's the ANSI code certification. Missing relief valve. I don't put every picture in the report, but a picture like this really just sums it up. And then there's the bottom of the tank again. This tank was not leaking at the time of the inspection, but there's a little bit going on right here. A little bit of rust, could be just condensation from the bottom of the floor. Hot water source from the boiler. There's the cold water coming in, hot water coming out. Tankless coil. The cold water goes into the boiler and goes into a coil and heated up and comes out. And it comes out scalding hot. If the boiler temperature is 160, 180 degrees, this water coming out, potable hot water, is that 160, 180 degrees. So there should be a mixing valve right here, allowing cold water to mix with the hot water. That's the boiler there. I take a picture of the temperature gauges to show the highs and lows. This is the hot water coming out, cold water coming in, so I can explain it later. I take the cap off, the cover off of the electrical connection, just to see that the grounding wire is connected to the grounding screw, and it's green. And there's a clamp there, properly sized wires. This is a boiler again, cold water coming in, and it goes into the mixing valve. Right there. There's the mixing valve. Mixing valve. Because a lot of these valves and fittings and tees, especially coming from a boiler, are never labeled. Hardly ever labeled. So if I can figure it out, I'm going to show my client. Another picture of a wire connection, an electric hot water tank. I follow the wire back to the source if I can. In this case, I wasn't able to. It goes into the wall and probably then drops down somewhere. That might be it. But it wasn't labeled at the time of the inspection. That's nice. It helps me out. Only a few years old, 2004, January 8th. Jackets void the warranty. Jerry, our master plumber, went over that. It's really unnecessary. These tanks are insulated with 1 inch or 2, some or more insulated than others, and you really don't need this. This only causes problems and avoids the warranty. That makes it easy too. It's great for recording, especially for later use. If you can't remember, or if you're not writing the report, maybe with a PDA, and you can't type it in immediately, or you're not holding a laptop in your hand, a tablet, taking a digital picture really helps. I don't put every picture in the report, but this one I probably would. So it's dated by somebody saying it was November 1997. If that's the right date, great. If it isn't, well, this is a leaking valve. Somebody put some rags around it because it was dripping. Oh, the flue pipe. Well, I start with a leaking valve here at this hot water tank, 1997. But then as I have my camera in my hand, I'm always looking for other things. And I think because I have my camera in my hand and I'm taking digital pictures, I slow down because I have to actually slow down to take photos that are in focus. And I see things that I may not see had I not had my camera with me in my hand. So here's the flue pipe. And not enough screws, not any screws. I want to see 3 metal screws per connection, even here at the hood. Well, the valve above is making water drip all over the place, and it comes out at the bottom of the tank. So I want to see if there's rust and corrosion on the inside, and there is. This is an older tank. Burner there. There's the bottom cylinder of the heat exchanger in the middle, and there's some rust there. So it's probably causing some damage on the inside as well. Great shot. And that really is hard to describe in words. That's really the essence of having a digital camera. So you can take those pictures. Self-explanatory. Oil-fired hot water tank. There's the burner. There's the flue pipe coming from the... this is the heater flue connection going into the chimney, oil-fired. And this is the clean-out. This is related to the hot water tank. The flue exhaust gases going up into the chimney stack. So I remove a screw. There's usually 1 or 2 screws. And I take this clean-out out. And this is beyond the scope of a home inspection. But sometimes I do it because I've just seen reasons to. And here's another one. This one was empty, so that one was empty. But this one, it's not where I want it. Too bad the cleanup or the draft damper isn't right there, where the connection to the chimney is. So I open it up and I actually stick my camera in there with my arm in my hand, and I go up the flue, in here, up here, and I stick my camera in there. And that's what I saw here. It's blocked, or at least mostly blocked, with debris coming from the old stone chimney stack. And the flue pipe there is starting to rust and corrode away. So that's what's in there. Looks fine there. But it's really hazardous. Hazardous to someone's health. Carbon monoxide. Oh, and then I'm pointing. And I think when you see these marks, when you see these corrosion marks here and there, coming out of exhaust, here, that's a good indication of a draft problem. And that's the problem of the draft. It's filled with masonry debris. Here's an old tank. Gas fire tank. There's no valve. No shutoff valve. Not above it, not near it. It should be near the tank, above the drip leg. So there's the flue pipe. And actually, if you just slightly pull this out, especially if it's not screwed well, which old tanks sometimes aren't, if you can pull that out, again, it's beyond what home inspectors do, but I sometimes do it on older homes when I know that there isn't a flue, a modern flue. And this, again, is partially blocked. So all of this is blocked, and this above is open. So it's really restricted. It's not doing anybody any good. It's a health hazard. Could kill somebody. Boiler, clean out in my hand, open it up, and it's just filled. Again, this one's more than half full, and it's starting to corrode away. If you want to go further, you can. This is a great way to use your camera and go far beyond a home inspection in order to save lives. Here's a homemade pan, catch pan. It's not going to do its job. And if it does and catches water, the discharge of the pan needs to go into an indirect waste receptor. It needs to be conspicuous so you can see the leak. Electric hot water tank, no relief valve. That's an easy picture. Everybody understands that. Here's the hot water tank area that Kenton described as a problem with confined space. And this is a typical series of digital pictures that I take if I were going to inspect this hot water tank. I take a lot. I take 200 to 300 digital pictures, even more, during a typical home inspection. So this is how I would take digital pictures. There's the plate. It says a lot of things, a lot of labeling. It says even the warranty, name of the manufacturer, the size. There's a close-up. There's the date there. It's a FVIR tank. There's the valves, cold water coming in, gas valve, drip leg. The valve is in the wrong place. According to our master plumber, he likes to put them above the drip leg so he can turn off the gas and then clean the drip leg. There's the thermostat controls. Shot at the top, especially if it's a draft, a natural draft, to look for carbon deposits. A good connection, screws, and inserted tongs there, and the connections with the, we saw that the cold has the drip leg and the anode is over there at the hot. Connections at the flue pipe connection with the heating system up. Clearance problem. You need at least 1 inch clearance. So this is a fire hazard. The drywall is in contact with the vent pipe. Taking the cover off to demonstrate that I did an inspection that was thorough. If I'm ever in court, I can say, Your Honor, I can't see the burner, but here's a picture of it. That's my restriction. FVIR vents, labeling, certifications. There's the 150 psi, the 210 Fahrenheit limits. Certification, there it is, there. And there's the size, 3/4 inch. It's conspicuous. It goes into a floor drain, indirect waste receptor. It's not hidden anywhere. A discharge pipe from a relief valve on a hot water tank cannot go directly into the catch pan. So this plumber was great, took it outside. Because at full flow, the pan cannot catch all the water, and the drain of the pan cannot catch all the water, the drain valve. And I'm not sure where that drain valve is. I don't have a picture of it. Probably behind the tank and I can't see it. And even if the pan, I believe the pan had a drain valve back here and it went to the wall, didn't go anywhere. And this was in a finished basement. So, big deal, the pan's installed, but where's that water leak going to go? It's just going to go on the floor anyways. The pan really needs to be directed somewhere. Here's another shot of a gas shut-off valve in the wrong place. And the missing cover at the burner. So there are advantages to taking digital pictures. So many digital pictures during your home inspection. One of the advantages is marketing, great marketing. Another one is communication. And another one is confirming that you actually performed your home inspection. This meter was not leaking when I inspected it, as my digital picture can show, can demonstrate. And there wasn't an expansion tank installed when we needed one. Just notice that there's a little bucket there. Could be leaking from above. This tank was not leaking at the time of the inspection. I have a digital picture to prove it. So it's really good for marketing and really good for keeping a record of what happened at the time of the inspection, what we saw at the time of the inspection, what was leaking, what was not leaking. and also going to describe how things work. Cold water comes in, hot water comes out. And nothing was scorched at the time of the inspection. You can write that nothing was scorched at the time of the inspection, but man, a digital picture really just makes it all worthwhile. And digital pictures are free. You can snap as many as you want. Just get a really big memory card and set your camera to the lowest setting. So those are some of the pictures that I took, and I encourage you to keep your digital camera snapping away.
So in taking this course, we have learned how to identify components of gas-fired and electric hot water tanks, how to recognize defects and safety hazards in relation to modern standards and requirements, explain how a flammable vapor ignition resistance system works, the importance of temperature and pressure relief valves, and we've learned how to check and identify confined spaces. Thanks for taking the course.